Okay, so so what are the Spark goals? Why they have to invent this new system, even though we have a couple of ecosystems available on Hadoop framework, which will be used for processing the data, processing different file formats, like different file formats, maybe structured data, semi-structured data, and unstructured data. The processing models, like you have the MapReduce model, and then Pig, one of the ecosystems which uses a high-level language like Pig Latin, and a few other ecosystems like even a Hive is also, and Plume, all will be using internally a MapReduce concept, right? So by finding out the problems in MapReduce, the limitations of MapReduce, implementing, and then the bottlenecks when you are doing the processing using that model, after finding out the difficulties, because there are a lot of data that we need to have to process, and then the process speeds need to be increased a lot. Okay, MapReduce is still where one even it is like 150 to 100 times faster than the traditional system, still, because of the emerging needs of the growing data. Okay, growing the data. So we need to speed up the processing. For that, and then the limitations of programming in the MapReduce, using the MapReduce model. So they came up with this model, and then to speed up the things, and then to reduce the number of lines of code to implement your business logics. Okay, and then lot of programming flexibility they have provided. Like you do the traditional programming, in the distributed programming also you can do whatever you do in the traditional programming language, the PLSQL code. Like you write a function, you write a procedure, and then you call that procedure, and then one procedure from another procedure, like, right? That wherever you want. Once you write a function, you can, okay, you can like use that particular function in multiple times wherever you want. That kind of programming model they developed using this Spark. So which is kind of like more flexible for you to implement the business logic with minimum number of lines of code. So that will have reduce the code maintenance and a lot of other advantages. So and then programming effort, and then programming time, testing time, all by keeping all these things in mind, and then to speed up the processing, because it is using a different concept. It is not kind of modified. It is not kind of a modified version of that MapReduce model. So what is the MapReduce model? What is how the MapReduce will work? Who will tell me based on our the previous sessions? So how the MapReduce will work? How it is doing the processing? A map and reduce, right? So how that model will work, what the API will do, and what the framework will do. As a developer, what you are going to do, okay? As a developer, how you write the code on MapReduce, how it will work. Who will explain about it? Take just 2 minutes or 3 minutes, or just maybe you can take 5 minutes, and then explain about that model, so that I can tell you what are the issues there in developing the logics. And then what are the limitations there? How it is the processing is getting delayed? What is the cumbersome process in this MapReduce model? Okay, so can someone talk about it? Anyone like Anil? Yeah, Josh Nagaraju told me that she cannot speak because she is with her son, so that she cannot speak. Maybe Amita or Anil, or maybe Naresh. Anil, yeah.
Yeah, MapReduce is a framework which is used for processing of data which is there in Hadoop.
Yes.
It has two components, map and reduce. And map will get data from the input files and store it in the local data sets. And after that, like shuffling and sorting phase is there.
No. Local data sets, huh? What store in the
Outputs of map outputs will be stored in local.
All the mappers output which is executed on single machine will be stored in the intermediate file, right? Intermediate files. Okay. Yes.
And later, shuffle and sorting will be there, and reducer will take the outputs which we get from MapReduce mappers and execute those. Execute those, and it will give the results. and the reducer.
Yeah. So on all these mappers output, okay, it will generate a final integrated file. On that integrated file, and then your reducer code get executed, right? On the based on what a key value pairs here. Everything is, that's the key point. That's what we wanted to emphasize. And then what is the cumbersome process is in this end-to-end implementation of this MapReduce distributed parallel processing concept? What is the cumbersome processing? What is the time-consuming process in this model?
Reading data from the local.
Okay. Reading the local, even Spark also first time when the file is stored on the local file system or Hadoop distributed file system. However, it has to load first time into the memory. After that, it will do the processing, right? So okay, reading the file, okay, that has to do with the either Spark first time when you are loading the file into the memory. After that, it has its own in-memory management system, Spark. It is efficient, that's okay. But first time, both will be reading from the input file, right? So in the MapReduce programs are MapReduce is like the data is processed in the form of splits, right? So your data is divided into n number of splits. Each split will be assigned with a map task, right, to process it. Once it is done, another map task, like that. So keep on processing multiple splits, okay? So parallelly, and then it has to wait. Okay, because if you are running out of the resources. But what is the cumbersome process in this process? I talked about it. What is the time-consuming process in this end-to-end processing? These are all the interview questions for you. Maybe you will be doing the actual job of implementing the business logics and all. So when you face the interviews, they ask this kind of questions. What is the time delaying process where you can reduce the bottlenecks in MapReduce? How you improve the performance of your MapReduce program? How you fine-tune your MapReduce programming? How you fine-tune your MapReduce applications? So
maybe like
come across. What are the techniques that you use to improve the performance?
Okay, maybe like interactive programming. For example, one mapper output will be given to another mapper as an input. So again, it will get the data from.
Again, one mapper.
When one mapper's output will be sent to the input to the other mapper. Like if there are parallel. No, I mean to say parallel mappers.
Yeah, if you say mapper means there is no sharing of the data between map tasks, right? That is the rule. Yeah.
Pipelining concept is there. That's the reason.
Yeah. Next pipelining means a completely end-to-end processing is completed. One mapper out. That's what you have to tell. Okay. So that's pipelining. You have to use that keyword. Otherwise, they will get confused, right?
Okay. Yeah.
Pipelining means one MapReduce output. That might be only map task or reduce task. It doesn't matter. So pipeline of MapReduce concept is that when the output file is written in the HDFS, then the next program will take it, right?
Okay. Yeah.
Okay. So what is the cumbersome process or time-consuming process? So because that from there you are coming to this. Why Spark is like a different processing model? What are the disadvantages of this MapReduce programming model? How you can improve? What are the areas that they can improve? So based on that, they don't want to create a modified version of MapReduce to improve the performance. They created a new engine, a MapReduce like engine, but not a MapReduce. It won't do the processing like you MapReduce is. It's having a different concept here, RDDs. A functional programming. You can use your functional programming too. So that's why you need to know, right? So what is happening is all these intermediate files created by your n number of map tasks, which will be working on individual systems. Okay, so all these intermediate files output needs to be shuffled to a machine where the reducers are running. One or more reducers are running. That means data traveling will be there, data movement will be there among the cluster of machines. That means, so you are incurring, not only you are consuming the time, processing time, not only that you are incurring the network bandwidth. Yeah, network bandwidth, right? So you are incurring. If you have less network bandwidth, so you have to wait for the other packets to transfer, and then you have to wait for it. That means you are incurring when multiple MapReduce programs are running, you will experience a bottleneck there, and then that is the delaying process in this entire end-to-end MapReduce programming. That cumbersome processing is the time-consuming process, is like shuffling process. Okay, where you can how to spill out, how it will spill out, how to define the spill size. Based on that, you improve the performance of your MapReduce programs, right? So for that, you have to do some configurations in the configuration files, or the throw programming or overridden parameters from your programs. You are going to modify the code and then improve the performance. Even though what are all the techniques that you use may not help you to process it, okay, process it very faster. And so that means it has its own limitations. Beyond that, you cannot do anything. You can improve the performance, but not at abnormal level. Maybe 2 times faster or 3 times faster, maybe little faster, that you can do. Okay, so by finding out all these bottlenecks of your MapReduce program, they thought of creating a new system, because you will be dealing with, you know that, right? By the year of 2020, you will be dealing with 35 to 40 petabytes, 40 zettabytes of the data. That means you need to understand how much faster systems we have to develop. Okay, so then they're doing more polishing on this Spark. The next generation of Spark they just released 3 days before, and then which is like 2 to 3 times faster than the existing Spark. Not I'm comparing with MapReduce anymore. Okay, it is 50 to 100 the current versions of Spark, the production versions of Spark is like 50 to 100 times faster than MapReduce. And then the current version, the new version which is released 2 days back, which is very faster, like 2 to 3 times faster than in the existing Spark. So that's what they are improving day by day with the future updates. Okay, that means you have that means we are trying to improve the processing speed, so that we can because we can deal with the large volume of the data, still can process it with the minimum time. Okay, so extend MapReduce model to better support 2 common classes of analytic apps. Iterative algorithms. Okay, what is an iterative algorithms? What is an iterative? What is an iterative algorithms? Iterative means run the same functions again and again. Can you do that in MapReduce? Anil, you cannot do that, right? That is the limitation in MapReduce, right? Once the map is completed, if you wanted to come and before the processing completes, can you come and execute that same map task or the methods which you have written in that map side? Can you execute those methods again?
No.
No. Once the map is done, it's gone to the reducer, that's it. After reducer is done, reducer output is written to the HDFS. You take that output file as an input to the next pipeline of MapReduce program, and then you write the MapReduce code, so that you cannot come back and execute the same code and again when you need it. That means you have a limitation there. And then again that entire cumbersome process needs to happen in order to get the next output. And then after that next output, and then you have to write a pipeline like MapReduce program in order to accomplish your final goals. That is the limitation, right? So here in this case, iterative algorithm, you can write the function. That function can be used elsewhere in your code. And you can go back and use the same function again and again. To accomplish whatever you want. Okay, so we'll talk about the RDDs in more detail in the next couple of sessions, so that we'll understand what it is doing, how it is different from your MapReduce model. Okay, so iterative data mining, iterative algorithms. Okay, what is iterative algorithms? Based on some conditions, else if conditions, right? Can you do that in MapReduce? You don't do that. You cannot do that, right? Once the reducer is done, you cannot do that. Okay, so that is the main issues with MapReduce. You have a limitations in programming limitations, lot of limitations, and then processing delays when compared to the traditional system. Definitely MapReduce is faster because you will be processing only a small chunk of the data instead of processing a big file, which happens in the traditional systems. Okay, so here that's how it is different here. Okay, iterative data mining cannot be done using MapReduce programming model and then using that MapReduce programming paradigm concept. So that's why they have to invent a new system. The result is Spark. Okay, so in Spark, how? Yes, someone is talking. Oh, Vinay joined. Finally, Vinay, you are late by 1 hour.
Yeah, chinna confusion వచ్చింది నేను.
Yeah, sorry about that. Yesterday I invited on 14, but
Sorry about that. Okay.
Not a problem, Vinay. So he just started, not a problem. We'll cross this because a couple of will be maybe short notifications. Not so many people are able to join because I have a lot of other participants, few participants. They are from references. They will be joining in our next session. We'll be talking about again on this the same. Might be we are going to repeat it. Don't worry about that. And then, however, I'm going to share this recording so that okay, we can hear that one more time. Huh?
Yeah.
Okay, Vinay, are you getting a chance to read the recordings of my previous sessions in my Hadoop? You missed a lot of sessions, right, Vinay, because of your tight timelines.
Yeah. I had a chance to do some things. Yeah, definitely. Yeah.
Please go over many this kind of a detailed the curriculum. That's why I invited a couple of sessions, but I don't know, maybe because switching between the jobs and then they are completely occupied with your job right now. So the good thing is Vinay got an opportunity to work on Spark. He is from Canada. He is my student in Hadoop. He is working. He logged in from Canada. He got an opportunity working in Spark because he is doing the testing right now. You wanted to get into the development area, right? A startup company he joined. So that's why he got an so definitely he will get an opportunity to do the coding also. Okay, so that's why he is joining my Spark session. That is about Vinay.
Yeah, thanks.
Okay, so now we are coming to Spark. So what does Spark do? How it is special? How it is different from a MapReduce programming model? Provide distributed memory abstractions for clusters to support apps with working data. Distributed memory apps. So it will work with working data sets are stored in the memory. Okay, so you have what's happened? Okay, so provide distributed memory abstractions. It will keep the working data sets in memory. Data sets means so multiple data sets. Like how Pig will work. How Pig? It is kind of a high-level programming language, right? Pig Latin. You write the Pig statement, right? What is happening? You write you store the data in the bags, right? In bags. I'll be talking about kind of making a revision between Hadoop ecosystems and then comparing with Spark initially to understand the concept. Okay, so how a Pig works? It keeps the bags in memory, right? Maybe may not be in memory, but it has the references to the data sets, right? The small data sets. You derive the you take a big file and then create a bag. From that bag, by applying transformation functions, you create another bag. So each bag which is giving you a separate set of the data, right? That's the model of that is the programming model in a Pig, right? Yes, Anil?
Yes, sir.
You define one bag, load the data set into that bag, and then you apply some filtering functions or like grouping functions, and then and then read that data set which is already loaded into the which is already available for you, compiled and get it ready for you, and then from that you are going to derive some more data sets, and then by applying some more transformation functions, you built-in pig transformation functions, you derive one more bag, and then you create one more derived bag. Like that, you'll be creating one more bag, and then you can display that bag content, or like if you wanted to store that particular bag content, you can store the data into either HDFS or local file system. That is kind of a starting point for Spark to think about this model. How I can say a very fine-tuned version of your data. Okay, so that way you can provide distributed memory access. All these data sets will be available in memory here. That's why it is a little bit different than Pig. Pig has a references. Here you have flexibility in your programming. Either keep those small data sets, so pieces of the data which is transformed data in the memory, make it available either in the memory or persistently stored in the HDFS file system or local file system based on which mode that you are working. Okay, whether you are accessing a local file system file or like Hadoop distributed file system file, and then load that data set into memory, and then apply some built-in functions on that data set, and then create one more data set, and then read that data set again, and then create one more data set by applying some more transformation functions, and then like that you keep on deriving multiple working data sets which are stored in the memory, and then it is readily available, and then parallelly multiple programmers can access those working data sets which are called RDDs, resilient distributed data sets, RDDs. That is the main winning point for the Spark. Okay, RDD in the form of we call them as an resilient distributed data sets. Why it is resilient, and then how it is distributed among the multiple systems, and then so that multiple users can access the same data set at the same time. Multiple users can read the same data set at the same time, and then derive and then one more data set by applying some transformation functions here. Okay, so that's what the provide distributed memory abstraction. That is the winning point when compared to MapReduce for clusters to support apps with working data sets. Okay, so retain the attractive properties of MapReduce. So what are the MapReduce has some limitations. It has some powerful features. It is retaining the concepts of the attractive properties of MapReduce. What are the fault tolerance? Okay, and then for crashes and stragglers, means fault tolerance means, so once the programming started, and then the first machine, the machine is failed, what are the blocks which are are split, which are getting processed in this system, okay, are processed by are processed in the other systems where the second copy resides, right? That fault tolerance here also, and then it has a mechanism, RDDs, resilient distributed data sets. Okay, it will store the lineage of those data sets. Lineage means like execution flow. It will keep the execution flow in the memory through lineage, its lineage, and then once it is kind of lost, so a particular data set is lost for different reasons, and then it knows where it is actually initially derived from the data set, so that it will go ahead and then build from there, and then restore the data sets once it is failed. That way it has a fault tolerance mechanism. The model is different, but the concept is the same. How it is implementing the fault tolerance, the MapReduce. So it has its own, Spark also has its own fault tolerance mechanism to retain the data sets and then recreate the data sets from where we lost. Particular data set that you are accessing, if it is lost, it knows where it is created from, and then it can execute the same functions what has been executed before to derive that particular data set, and then give you the data set, so that no processing, no stoppage of the processing. And then data locality feature, where it is the data is stored, it is getting processed. That is the it is the powerful feature of this MapReduce, so that your processing speeds will be increased. It is also retaining the same feature in the Spark also. Scalability. When it is like Spark, remember that Spark is designed to work with any file system, local file system, remote file system, or like Hadoop distributed file system. And then it is kind of an independent framework which can be integrated with Hadoop. It is and then it has a like mechanism to access the use the storage APIs, HDFS storage APIs, so that it can read the data which is stored on Hadoop distributed file system, as well as it can read the data set which is stored on local file system, and then write the outputs to local file system like your feed. Okay, so that's why when it is integrated with Hadoop, it is scalable. Spark is scalability. So scalability means you can process any amount of the data, using the resources of the and then shared pool of the multiple systems. That means cluster of machines. It will use the scalability. It is retaining the scalability feature of the MapReduce concept, which is a programming model which is initially designed to work with Hadoop distributed file system. Okay, so it is retaining those features. Any questions so far? Anil, Naresh. Okay, so now the solution. You got the problem. You understand the issues of the Spark. Very good. Thank you. Okay, so that's why now the solution we are coming about what is the solution for these issues faced by your MapReduce programming model, and then the result is the solution is resilient distributed data sets, RDDs. We call them as an RDDs. We talk about more about these RDDs. Like we'll take a couple of hours to understand this concept. Okay. So we will talk about actions and then transformations on the RDDs. Okay. So resilient distributed, resilient means never dies. Those are available all the time, whether they are died, and then they will be created. That's what resilient means. A distributed, available, distributed in a distributed way, so that multiple users can access the same RDD parallelly. Okay, allow apps to keep working sets in memory for efficient reuse. You can store based on the memory availability, memory usage. You can keep some small data sets in the memory. And it is so big to store it in the memory. You can persistently store that particular data set persistently into the HDFS file system whenever you need it, and then it will get the data from that main RDD which is stored. Okay, either you can store the memory as well as the hard disk, or and then only in the memory, only in the hard disk. Like that, we have a different programming model, so that based on your requirements and then based on the available resources in the Hadoop cluster, okay, you can use the different memory models. Okay, a fault tolerance, a fault collection of elements that can be operated in parallel. Collection of elements, like you can create the RDDs. You take one RDD, and then from that you can create one more RDD, one more RDD, one more. Reading that particular RDD, and then create one more RDD by applying some transformations on the existing RDD, and then create a new RDD. That is a new RDD which is holding some other set of the data. Okay, and then one more RDD, it is having some more fine-tuned data based on your requirement. In an individual RDDs, you know what RDD is giving me, what kind of the data is stored on that particular RDD. Based on that, and then you play with these RDDs, multiple RDDs which are available either in the memory or stored in the HDFS file system. A fault tolerant collection of elements that can be operated in parallel, so that once the data set, when the RDD is created, that can be used by the multiple users of the Hadoop cluster. Parallelly, they can use it. Okay, creation of RDDs, different ways of creating the RDDs. A resilient data set, a different programming model. Okay, how you create the RDDs, so that they will be available in your memory so that you can use them. Okay, creation of RDDs, parallelizing an existing collection in your driver program. So you initialize the data, right? Initialization, you will be reading the data set from the either local file system or HDFS file system. When you first time loading the data set from the physical storage space, and then you parallelize the data set. Okay, this is kind of a function that you use. Okay, and then you create a Spark context. We are going to talk about that API Spark context, how you create the Spark context programmatically, how you initialize that. Okay, like you initialize the APIs in MapReduce. Okay, you use a parallelize function so that you use the parallelize function automatically. That function will be available as an RDD in the memory or in the physical storage space, so that can be used by multiple users of the Hadoop cluster. Okay, so that means parallelizing existing collection in your driver program, referencing a data set. Okay, so you refer a data set in an external storage system such as shared file system, HDFS, HBase. When HBase uses RC file system, right? So you can read the RD. So all, like I said, right, it is integrated with all the, it can understand all the storage APIs. That means what are the file formats supported by your MapReduce, and then supported by here Spark also. What are the file formats it can read, and then Spark also can read and use the same like Percute file formats, Avro file formats, and then all these file formats, and then key value file input file formats, simple text input file formats. All these file formats supported by your traditional MapReduce programming will be supported by Spark also. You can create the RDDs by taking any of these files which are stored in different file formats. We already know about input file formats and output file formats which are supported by your MapReduce programming model. The Spark also has an ability to read all these file formats. Okay, or any data storage offering Hadoop input format, any data storage. So it has that way, by taking those data sets available in the physical memory in different file formats, and then you can create an RDD which is available. Once we create an RDD by reading a particular specific file format, and then you can read that particular RDD and apply some transformation functions, and then a derived RDD can be created. A new RDD can be using a feature called transformations. Again, you read the RDDs and then get the data. Either way, those are called actions. We are going to talk about in detail about that. Now coming to actual Spark. Okay, what is Spark? Apache Spark. Fast general engine for large scale data processing and analysis. Okay, so it is we can say here, we can add one more term here: in memory data processing model. Fast general engine for large scale in memory data processing system. So, why they did not hard code it? Because you can retrieve the data which is stored on HDFS, not only the data which is stored on in memory. That's why they just said a large scale data processing and analysis. For doing analysis of the data, we use this Spark, fast general engine for large scale data processing and analysis. Okay, open source, developed at UC Berkeley. Open source developed at UC Berkeley, and then Miti Jaharia is the person who has created this concept at UC Berkeley. He did an R&D on this MapReduce model and find out the problems in that and then bottlenecks in MapReduce programming model. He developed initially. He did a lot of work on this and then derived this initial versions of this Spark. Open source developed at UC Berkeley by Miti Jaharia, M-A-T-I-D Jaharia. Okay, so functional programming language that runs in a JVM. Okay, so it has more flexible programming models. So you can apply WOOPS concepts. Yeah, you can use Java language to implement to create the RDDs, or like you can use Java APIs. Okay, and then you can use the functional programming using Scala or Python language. Functional programming is functional. You know that, right? C language is a functional programming language. You can write a function. You can use it elsewhere in your subsequent steps. That function multiple times here and there. Okay, come back, go there, come back, like that. In the same way, they made a flexible programming model here, Apache Spark. No limitations there. Like you are comfortable with a traditional programming language, so that all those concepts will apply here. That's why it is kind of winning the race in the market. It is booming in the market. Why Spark is kind of booming? Everybody in future, maybe in couple of years, MapReduce is gone. I'm telling you. Okay, MapReduce is gone because Spark is doing everything. One framework is doing everything. It is dealing with structured data, semi-structured data, and unstructured data. It is having multiple language support like Scala, a native support, Python, and Java language. Now the latest versions, which starts from 1.6, it has support for R language. Maybe in future we will be seeing a support for more programming languages. Okay, so that's why it is a functional programming language that runs on a JVM. So initially it is this Spark is written in Scala, more powerful language. It has all the like your Java concepts as well as the functional programming concepts. Okay, so you can using Scala you can do OOPS programming as well as functional programming. Okay, we'll be emphasizing more on when you are learning Scala. We are emphasizing more on functional programming because it is kind of an emerging, right? That means you can reduce the number of lines of code. More flexible functional programming language that runs in a JVM, not a modified version of Hadoop. It is kind of an entirely a new concept is built in this Apache Spark. Separate, fast, MapReduce like engine, not like MapReduce, a modified version of MapReduce, like engine. Okay, yeah, that means in what way you compare with MapReduce, it is kind of a processing model. Whatever you can do with MapReduce, you can do, and then you can overcome the limitations of your MapReduce programming, and then you can eliminate the bottlenecks of MapReduce programming, and then to speed up the processing of your programs. In-memory data storage for very fast iterative queries. Keep changing using the same functions again and again on the data sets which are stored in the memory. In-memory data storage for very fast iterative queries. Okay, compatible with Hadoop storage APIs. That's what we discussed about, right? Storage APIs. That means it can support all the input file formats supported by your MapReduce APIs, and then it can access the data which is stored on Hadoop distributed file system. That way, it is compatible with Hadoop storage. It is kind of an individual framework which can be integrated with either local file system or Hadoop distributed file system. So it has compatible with Hadoop storage APIs, means HDFS APIs. Okay. So to talk about Spark architecture, how it works, what are the basic components of Spark, and then Spark shell, Spark applications, Spark context, RDBs, how you create the RDBs, and the memory management. Okay, so yeah, we talk about whatever we can complete within another 15 minutes, and then so that I can 10 minutes, so that I will show you one program how you initiate the cell. Okay, so the installation of Spark and developing the programs either using Eclipse, how to using Maven APIs, and then how to like build your programs in sorry. Okay, so here using just Eclipse, how you run the programs here, different programs, how you can implement Spark streaming, how you can implement MLA programs, how you can execute your okay, I open up the other session. So okay, MLA graphics. Okay, so you can use either the Eclipse to deal with to test your program, because it can be integrated with either local file system or Hadoop distributed file system, or you can use HDFS inside that virtual box. I will tell you how to install it, and on the 4.7 version. So 5.6 means it is already available as one of the ecosystem. 5.6 version of Cloudera comes with Spark, like as one of the ecosystem. Okay, and then using if you are using the older version because of the memory issues, right? The system memory memory limitations. We can use that Cloudera 4.7 version. Still, you can download the parcels at Spark parcels and then install on 4.7 version. I will tell you that also. And then if you have more memory like 16 GB or something like that, you can use the latest versions of Cloudera, so that Spark is already available. You don't need to worry about installing the Spark separately. You can just go ahead and use it. Okay. So this is the program, and once we talk about it, we are going to execute at least one Spark program using this shell, Spark shell. Okay, Scala shell. Okay, Spark architecture. What are the basic components of Spark? Okay, how it implements the how you submit the jobs, and then how it will take. What are the components involved in executing that? What is a worker? What is an executor? Like your master slave architecture in Hadoop, right? In Hadoop daemons, right? Name node and data node. Like your resource manager and node managers in the case of Yarn. Okay, like that, it is kind of a master slave architecture, right? So that is kind of architecture that you have in Spark also. User master worker architecture. Okay, so uses master and worker architecture. Okay, so the basic components of your Spark architecture: a driver, a cluster manager, and then master and workers. Okay, so these are the basic components of your Spark architecture. What is driver? Talk to a single coordinator. Okay, talk to a single coordinator, splits application into tasks and schedule them to run on executors. Splits application into tasks and schedules them to run on executors. So executors, like maybe it can use a different resource managers. Like we can use Mesos. Mesos is one of the resource management and open source. Apache Mesos, you might have heard about that. It is kind of one of the resource management tool which can be used in Spark also. Okay, you can use Yarn also, yet another resource negotiator, in which a different kind of a resource management system. It can use that, and then Spark it has its own resource management system. If you want to integrate any of these resource management systems like Yarn or like Mesos, it can use its own resource mechanism to allocate the resources to the executors. Okay. Okay. Coordinate workers and one overall execution of the task. That is the program with the driver. Okay. When you submit a job, it is the responsibility of the driver to take that request and initiate a Spark context. It is kind of a starting point to your API. A Spark context is created. When you initiate a shell, we will have a look at it. When you open up a Spark shell, by default, okay, a Spark context is created. If you write the programs in Eclipse, you have to initiate that API. A Spark context needs to be created, which is having a different methods, and then you can create a Spark context and then name it as an SC or something like SC dot, and then it has multiple methods. You use those methods to implement your logics, and then use the programming. And do the programming. A Spark context is created, which is created by the driver for each application. You submit a job, I submit a job, and another user submit a job. Okay, so for that, a driver will take all these programs and create a Spark context, which is kind of initial point for your programs. Okay, for your application, for running your applications, and then it interacts with the cluster manager, and then submit the jobs, and then try to execute the job in the different in the workers, means like workers are the slaves. Okay, and then on the executors, which is getting the resource, executors will get the resources from the using the resource management tools like Mesos or like Spark is having its own resource management mechanism, or it can use the yarn resource. It can integrate using the yarn. It can run using the yarn. You mentioned that when you are submitting that, which resource manager that you are going to use, either Mesos or yarn resource manager or local resources management. Spark has its own processing, has its own resource management system. So if you don't mention any Mesos or like yarn to execute your programs, like you submit your programs, when you submit a MapReduce program, you write Hadoop jar or like yarn jar file location, your input file, and then jar file location, your package name dot class name, and then input file path and output file path. Like that, it has a command to execute the programs from your directly from your Linux command line interface. Okay, in that you mention which resource manager that you want to run your Spark program, so that it can use that yarn, either yarn or Mesos, Apache Mesos, which is also an open source resource management tool. That's what the cluster manager comes into picture. So cluster manager means which will manage the cluster resources and then allocate the resources based on how much memory it needs, how many cores it needs. Okay, cluster manager. An external service to manage resources on the cluster, yarn, Apache Mesos. Okay, you can you mentioned that which resource manager that you want. Like you run MapReduce program. If you wanted to use job tracker and task tracker, you say Hadoop jar. If you wanted to use yarn there for running MapReduce programs, what you say yarn jar, so that it use the yarn daemons like resource manager. You might have remember about the that yarn, like we talked about yarn when we talked about the complete course. Yarn, right? Yarn resource, yarn architecture, right? Yarn means resource manager, node resource manager is the master, node manager is the slave, and you have a container. The memory allocations will be done, either core and memory, and will be done through containers. And then you will be we talked about application master. One application master will be created by the resource manager for each application request. Okay, so like that kind of resource management it is using to allocate the resources to the workers for executing the your Spark tasks. Okay, master manage workers. It's running Spark instance that connects to a cluster manager for resources. Okay, so that's what it connects to a cluster manager in order to get the resources and then allocate the resources to your workers to run its task in the executors. Where the executors live to execute the task. Okay, workers. These are all the workers in which you execute the task in the executors. Okay, these are the basic components of your Spark architecture: driver, cluster manager, master, and workers. In between, you will have either in the cluster management you can use yarn or Spark. You mentioned that. So there is not much that you can do with the resource management tools. You just tell the tool which one you use to execute your programs. Okay, that is decided by your environment, what they are trying to use based on the administrator, and then you work together to execute your jobs, either using Mesos or like yarn. Okay. Yes.
Because like an optimized resource allocation can on the uncle like if I Spark configurations lo like I want to retrieve data the fastest anamata, like how to do, like how to say
configurations fastest way.
Yeah.
What is your actually issue that you are facing? You sent out an email, right, on the other day, but I was busy in the hospital and then I could not even look at it. So maybe, however, we are kind of talking about that, and Okay. So what is the issue that you are having there?
I sent you a picture, uncle, on WhatsApp. Um, ఏంటంటే like we have all these things అనమాట, like all the Spark configs.
Configuration files, right? Yeah.
Yeah, we have like
.sh.
ఏంటి uncle?
Spark env.sh.
Spark env.
I don't have that. After that, I did not get a chance to look at it.
I'll send you again, uncle.
Yeah, send it again, or otherwise in the next class we'll address about it. Okay. Okay. So there is configuration list, which will speed up the process. That's what you are checking about, right? Which configuration affects that speed up the processing. That is based on your requirements. What kind of data that you are processing, it varies. The configurations, hundreds of configurations will be there in the Spark env.sh, and then multiple configuration files based on the schedulers also. So it is kind of trade-off between the things, where to look at the things to do to make the to change the configurations to speed up the processing. Sometimes a trial and error method you have to apply for your processing, which needs to be which will be working. Okay. So here, so now what is Apache? Spark shell. Okay, so an interactive shell directly you can execute the write a Spark program in Eclipse, develop that Spark program in Eclipse, and then you export it as a jar file. Okay, you can execute those programs either from command line interface or command by command. You can execute, like you execute the command to escape statements from Hive shell, or execute pig statements from pig shell. So it provides multiple shells for it comes up with 2 shells at this point. Okay, so a Python shell or Scala shell. Okay, so initially when you open up a shell, a Spark shell, automatically by default Scala is the default shell. That's why it will open up a Scala shell. Okay, Spark shell, interactive REPL. Okay, interactive REPL. REPL means read, evaluate. One second. I will be back in a minute. I will be back in a minute. Okay. So maybe we will take just 3 minutes break. Yeah, sorry guys, one of my relative from a far distance came. I had to spend at least 2 or 3 minutes with them. Okay, sorry about that. Okay, so now, so you are going to use a REPL, means an interactive shell. REPL means, okay, read, evaluate, and print loop, right? So that means it's providing a shell like your pig shell, so that you can execute the your Spark functions from that shell. So to implement your business logic. Okay, so right now the REPL is available is REPL is available for Python and Scala, both languages you are providing. And then if you wanted to use the OOPS concept, you can write your programming using Java and Eclipse or something, and then execute the programs. Okay, Spark applications for large scale data processing. So you use the Spark application. You use either Python, Java, or Scala, or R from 1.6 version of Spark. Okay, so we'll okay, so when you open up a Spark shell, okay, if you are using a REPL, and then automatically a Spark context by default is created. Every Spark application requires a Spark context. We'll talk about more about the Spark context in the next couple of sessions. Just it's kind of like I wanted to show you one program, a map word count program, which is having like 200 to 250 lines of code in your MapReduce, and now using this Spark shell, using Scala language, and then using the Spark functions. So how many number of lines of code is reduced? You'll have a look at it. Just one line will be implementing all that logic, a main logic. Okay, so that's what I will execute that program and show you how it is flexible, how it is powerful than your MapReduce programming model. Okay, every Spark application requires a Spark context, which is kind of a starting point of your API, the main entry point to the Spark API. From that, okay, once the Spark context is created, and then you call multiple functions of that particular Spark context based on your requirements. Spark driver is the process that creates and owns an instance of the Spark context. Spark driver for each application, a Spark context is created, right? Spark driver initiates that thing, a Spark context. Okay, Spark shell provides a pre-configured Spark context called SC. That the context name is SC. You see that in the Spark shell when you initiate a Spark thread. Okay, we talk about more about the RDDs and all, how you create the RDDs, what is the meaning of these RDDs, and then what way you are going to create an RDDs. So we just talked about the theory right now. So because we are coming to like 9:30, we are going to execute a program here. Okay, so like this. Okay, so like this, I have a development environment name in my local file system, Windows file system, using the Eclipse. Okay, I configured Maven and then written the code in using Scala, like Spark streaming, and then I have so different. So you have Spark streaming, different examples based on what you are. We will be talking about Spark streaming, like how to process live. It is kind of a good competitor. It is kind of almost in future. Maybe Storm is like outdated also, because it is the one framework, Spark. So we are going to talk about the differences between Spark and Storm in dealing with the live data, streaming data. So like data coming from the online applications, or like from other programs, they are getting the data, or getting the data from the social networking sites like Twitter or Facebook or LinkedIn, and then you take the data, streaming data, and then you can create your own batches, and then deal with the online streaming data. I can have a couple of examples ongoingly. I'm going to talk about the examples on different modules. Like you have a Spark SQL. We can interact with the Hive also. We can get the data from Hive and then apply the SQL language. Okay, then write the SQL queries from your Scala programs from here. Okay, they're using the Spark APIs, Spark SQL APIs, and we're going to talk about the data frames and all, and then that is about Spark SQL, and then we'll be talking about Spark streaming, machine learning libraries. Before that, the old model is Mahout. Mahout is outdated. There is no support for the Mahout right now, except the applications which are using the same available APIs, they are using it. Otherwise, everything is moved to the Spark MLlib, which will be implementing like your recommendations and a lot of other concepts of your MLlib, machine learning libraries available in Spark. Okay, you can do graphics. Okay, so all these modules are available. Once your concepts are clear, once we learn the Scala and all, we are going to do the practical implementations of all these kind of different modules that we are going to talk about. For now, I am going to execute a MapReduce program from this shell. I opened up this shell. Okay, I opened up the Scala shell. How to open up the Scala shell? Exit. If you wanted to exit it, exit. Same thing, same command. Okay, so Spark shell, which will open up a REPL for you, a Spark shell from where you can execute the commands. Okay. How the code is different? Simple code. Okay, complete MapReduce implementation is done using these 3 lines of code. So the first line, you are loading this data set. Okay, and then the second line. Okay, it is too early to talk about this because we will be talking about once we learn Scala and then Spark functions, transformations, and actions. It is meaningful. Just I wanted to show you the code, the difference between a MapReduce code, how simple it is. Okay, how you do the functional programming in here. Okay, so word count example, everybody is comfortable there. So that's why I took the same example and then making the comparison between the MapReduce code using Java and then the same word count implementation using Scala and then the Spark functions in Spark. Okay, so where text file, you are loading this text file. Okay, you are loading this text file into this variable. Okay, st.sparkContext.text file, which will read the input from this location. Okay, input location. Okay, and then make it available. And then okay, so text file is available. It is stored in this text file, which is kind of an RDD. An RDD is created. And then a resilient distributed data set is created. From that, I am creating one more RDD called counts by applying the transformations on the previous RDD, taking the text file which is handling the entire content of this Spark WC input file. Okay, and then on that I am applying some transformations like a flat map and then split function. Okay, that's how split function is used in MapReduce, right? The same thing, and then you are like creating encapsulated functions. This from this you are deriving. The output of this will be fed into this. The output of this will be fed into this, and then applying multiple transformation steps, multiple transformation functions step by step. Finally, the results will be stored in this counts. In this count by the execution. By after execution of this, so what you get in the counts, you will get a word like a keyword and then how many times it has been repeated. One line of code which is replacing your 200 lines of your Java programming code for writing your MapReduce, MapReduce program. So which is kind of one line of code, except if you don't take this driver class, which is kind of loading the data into this file, and then one line of code. This thing is just save the output to the HDFS in the form of an output file. Okay, this function is counts.save as text file will be used to store the file. So that means one line of code is implementing all the business logic, right? You are using encapsulated functions to implement it. So that's why very with the minimum lines of code, okay, you are going to use to implement the business logic. Okay, so we are going to use it to execute this. Okay, Scala shell this. Okay, it is loaded into text file. So next line I am using counts, copy. It is actually having the data. The counts is having all the values, the keyword, and then how big file that you process. It will having all the data. Okay, a word, and then how many times it has been repeated. When you actually submit it from the command line interface, you will find out the difference between the MapReduce program and this in regards to the execution time. Okay, and then the final step is storing the data. The results of your counts will be stored to an output file here, output location in a HDFS, user cloud era. Yes, and maybe this directory is already available. Output maybe 9. Okay. Maybe I did not started that. The task partition is deprecated. Instead, use MapReduce task partition. Permission denied. Root access right. User cloud era. Right permissions. Access control exception. Permission denied. Okay, I understand it. Okay. CD home cloud era. Okay, yeah. Because in order to initiate that UI, I logged in as a root user. That made a difference. Permission issues to write into Hadoop distributed file system. Okay, so now store it as and open up the other session. Before that, I logged in as in order to initiate the cell. I logged in as root user. That made a difference before. Copy. I will open up the other shell. Hadoop fs -ls part 0 file will be created, which is having the output. Okay, so Hadoop fs -cat So this is the car, river and beer. The same example, river 30 times, car 40 times, beer 20 times. That is the input file. Okay. So with one line of code you are getting, if you omit that loading the file initially and then writing the output to a distributed file system, and then the entire coding is done in one line. That's what happening here. So that is a simple way of reducing the lines of code using the high-level programming languages, which has the power. Scala has a power to call the Java APIs, okay, and then use the Java APIs, as well as it has its own functional programming model, which will reduce the coding effort and then faster development, and then more and more flexibility, and then in your programming. Okay, so a word count program. Okay, just we are jumping into the next step. I just want to show you a program, how a program will be executed. What is the difference between that? Okay, so in our next class, what we are going to talk about is we'll continue the session from here, or otherwise, if some people are joining, if it is possible, I try to conduct the class separately and then start it from here. Actually, where we left off today. Okay, and then after this we are going to talk about the installation, different ways of installation, how to set up an Eclipse in your local file system in Windows environment to develop your programs. And then we are going to, after clearing about, and then after that we are going to jump in and talk about learning Scala, and then after that we'll come back and then use that Scala language power that we learned so far to write your Spark programs. Yeah. That is so yeah, go ahead and look at that the curriculum that we sent. And then any questions so far? Did you like Spark? Yeah, just Nagaraju, yes, thank you. And okay, so I will send you an email when you are going to start. Before that, so you are just whatever the time is comfortable, either weekends, and so if weekends, what the time is comfortable for you. Okay, give me kind of more flexible time so that I will also can plan on the things based on majority of the people consciousness. Okay, so let me know either morning session or evening session. Yeah, thank you, Naresh. Yeah, call me after this, Naresh. I wanted to talk to you. Okay, okay. So anything else before closing the session? I will communicate. Just before that, you send me the communication, your confirmation emails, and then in that you tell your availability timings, either morning session or interested in the evening sessions. If so, what is the time zones? What is the time? Okay. So tomorrow there won't be any class. Maybe our Wednesday or Thursday we'll start the next class, or maybe if we are planning on weekends, we'll maybe next weekend. Okay. Okay. Any questions, Anil, Josna Garu, and Naresh? I want to talk. Vinay.
No questions from my end.
Okay, okay, Andy. Okay, thank you. So have a good day, guys. And okay, Anil.
Yes, sir.
Okay, so we'll get in touch. Okay, I will talk to you tomorrow.
Okay.
About that thing, I talked to someone else there. Okay, I will talk to you tomorrow.
Okay, sir.
Okay, guys. Okay, Josnagar, thank you so much for attending my morning session and evening session, and thank you, Naresh, for becoming my student. Okay, so okay, guys. Have a good night and good day.
Thank you, sir.
Welcome.